Thank you all for being here. This is a conversation about how to intelligently adopt GenAI to avoid productivity loss. And I'm Sasha Rosenbaum, Czarkowski now. I changed my last name so you can never spell it again or find me on the internet. You have to literally take a picture of this slide to be able to find me now. And I've done a bunch of things. I've been in tech for over 20 years now, and I've done a bunch of roles across different departments in technology. Tend to get excited about the new things and go chase the shiny bits. And I have recently started a new business with some very intelligent people, and we're working on a book, and it's going to be epic. And this is as much self-promotion as I want to do. So what about you? So I've been told that not everyone here is in software development. So first of all, who is in software development? A bunch of people. Security. Cool. Marketing, a couple. Sales. Anybody I haven't mentioned? Different departments? What do you do? Platform engineering. I mean, I count it as software development, but yes, valid point. Anybody else I'm forgetting? Finance, anything like that? Okay. All right, so full disclosure, again, I'm going to dump a lot of information on you. If you want to talk about anything that I'm talking about, please find me after this or online. So I'm going to say things that are not completely positive about GenAI, and this is why I want to preface the talk with, I'm actually very, very excited about this technology. I think the transformers are the most transformative technology in like 2 decades. It's really, really cool. But we have to be intelligent about how we approach this technology, right? So before I talk about a bunch of studies, have you ever asked an LLM to generate an image? Most people here have. So sometimes I give it a simple prompt and it generates something fluffy and amazing, and I'm just, super happy on it on the first try. And sometimes I'm like, I want a slide on DevSecOps. Not great. Second time, not great. Another time, another not great. 2 hours later, I'm sitting there doing, okay, I should have done it by myself. I should not have relied on ChatGPT or whatever technology I was using. So this is called intermittent reinforcement, actually. There is a psychological phenomena where animals and people will work much harder for intermittent rewards than they do for reliable rewards. So if you give your dog a treat every second time the dog performs the trick, they're going to learn much faster and work much harder to get the treat. It has a lot of dark side. So this is how casinos work. This is how people get addicted to gambling. This is also how our social media currently optimizes us doom scrolling forever. They don't actually give us rewards all the time. They give us some rewards some of the time, and so we get addicted. So I think GenAI is an accidental experiment in intermittent reinforcement. This technology wasn't intentionally designed to do this, but it does give us intermittently great results, right? And then we can find ourselves in a doom loop just pressing the lever over and over again, trying to get something that look good. And then, interestingly, one of the studies I was looking at was saying that your feelings about it might be wrong. So they measured productivity of people coding with GitHub Copilot on how good they were at task completion time and success rate. And they measured and they said they weren't any better at completion time or success rate, but they felt good about it, right? So you might be feeling really good about your productivity with GenAI, and it might not be informative about your actual result. So if I'm talking about productivity, this book is 40 years old this year. It's called The Goal. It's sold some 10 million copies. It's one of the most popular business books on the planet. And one of the quotes from it is, what I'm telling you is productivity is meaningless unless you know what your goal is. And a lot of times when we start looking at something, we don't actually tell ourselves what our goal is, right? So all of our measurement are not necessarily informative. And your choice of productivity metrics actually determines almost everything about your outcomes. So I'm going to quote a bunch of papers, studies, and stuff that came out recently. So Klarna International, that they saved like $40 million by implementing an AI-powered chatbot agent saved so much time, increased customer satisfaction. In general, chatbot agents are regarded as one of the killer apps for GenAI potentially. This is a recent study, I think, from a couple of weeks ago, and IBM did a study with 4,000 customers, and they discovered that only fewer than 30% of clients were happy interacting with a generative AI virtual agent. And this is the killer app, right? If you're in software development, you've probably seen the number 55% more effective. So this is a study done by McKinsey a couple of years ago about people using GitHub Copilot. They were apparently 55% faster at implementing a particular task, writing a web server in JavaScript. Right? This has been referenced a lot. New study from UpLevel, this was also a few weeks ago. We will notice that the sentiment changes over time, right? And so they actually measured and discovered there was no significant change in efficiency metrics with people who coded with GitHub Copilot. I used to work for GitHub, I'm not picking on GitHub. And they actually increased the bug rate, right? And in general, if we're going outside of coding, 77% of employees reported that AI has increased their workloads and hampered their productivity. More from this particular study, there was 37% of companies already mandate that they use generative AI tools, and 47% of employees in these companies say that they do not know how to achieve the productivity increase that their employers demand by using AI tools. So this is very interesting. Why is the data so different? One is what you measure, right? Second is who's paying for the study. And the third, I think one of the major effects is we tend to think that automation solves all of our problems. And this is a thinking that we fall into repeatedly. So this has happened before. We used to think that robots will solve all our problems. So like right now, if we take anecdotally right now, there's something posting about how their company is mandating that they switch to Cursor IDE using AI. And they're like, I just love my current config and it makes me productive and I have no idea how to deliver better results when I'm forced to switch my tools. So if we go into robots revolution, so Tesla in 2017 said that they were using over 1,000 robots for a Tesla assembly line, Model 3 assembly line, and they just basically tooted all over the media that no one's using as many robots as them. They're going to achieve magical productivity results. They're going to produce 20,000 cars by the end of the year. They actually produced less than 3,000 cars by the end of that year. Eventually, Musk was quoted saying that maybe they used too many robots on Model 3 and that led to delays. They eventually reached the 20,000 cars a year, but they had to urgently hire lots of people. Those people ended up sleeping in the factory, working around the clock, and there was a lot of safety incidents because the assembly line was built with automation in mind, robots in mind, not humans, right? So safety procedures were not followed. So interestingly enough, we think of Tesla as this revolutionary thing, but this has happened before. So 40 years ago, 40 years prior to that, in 1980s, GM spent $45 billion in 1980s money on industrial robots for car assembly lines. Literally the same story, right? Because we don't learn. So the CEO was touted as visionary 21st century futurist and whatever. They built all these robots because they feared Toyota. So they feared Japanese car makers, and they said, oh, Japanese car makers are coming for our market, so we're going to build all this automation, and we're going to win. In 1990, their earnings per sale plummeted more than 10x. And in general, this is someone interviewing saying that they spent $45 billion. For the same amount of money, we could buy Toyota and Nissan outright, which would have immediately increased GM market share by 40%. Instead, their market share continued to decline to this day, and this robot revolution was actually regarded as the first step in their downfall. The rabbit hole keeps going, right? So we love the terms sociotechnical and ergonomic. The origin of the term sociotechnical comes from studies by Eric Trist in 1950s Britain in coal mining. So there was, I'm not going to dive into details, but there was an old system which was mostly manual. There were people with pickaxes hammering at the wall, right, getting the call, and then shipping it upstairs. And then they basically created a big machine that the machine was shaving the coal off the wall of the mine, right? And then the people needed to just only shovel the coal onto the conveyor, and that was shipped upstairs. So they all believed that there's going to be a giant productivity gain because we're moving from this manual system with a bunch of people with pickaxes to this giant machine and everything's mechanized and automated and it's going to be great. It wasn't. It didn't generate almost any productivity gains, right? And Eric Tris did a bunch of study talking about why it didn't generate productivity gains and how to improve the situation. And all of his findings were dismissed because they're like, yeah, that was only relevant for this particular case. We're just actually going to move on and, dismiss the findings. Because we all love, top-down bureaucracy and the people in management think they know better. So we keep making this mistake of thinking that automation actually is going to solve all our problems. And why doesn't it? Like, it seems obvious. I used to think, at one point, I had a tagline in my bio, like, automate all the things, because I thought, like, if we automate everything, everybody's going to be more productive, and it's going to be no human error, and everything's going to be peachy. But it's actually not that simple, because our systems are sociotechnical, right? And so we have a human in the system and a technology, and we have to work together. And if we don't think about the human, then we end up with problems. So this paper came out recently in February this year, and it's Ironies in Generative AI, and is kind of referring to a paper that's much, much older of ironies of automation. This paper cites a bunch of ways. So they aggregated studies from human factors research in very many different fields in the past 40 years. And then the recent studies in generative AI, a lot of them are in GitHub Copilot because that was the first tool that came out, but also in different fields like writing, like image creation, like media. So they have a bunch of ways in which automation, like generative AI, can hurt. And again, this is something that happened previously in other fields. I'm going to quote a couple of them that I've personally experienced and I feel like I relate to, right? So first thing that automation generates is this production to evaluation shift. I like to call it creator to curator. You used to write code, and then you evaluate if the code is good. You're used to make marketing copy, and now you have to evaluate if the marketing copy is good. So at one point in my career, my job was to stare at a bunch of dashboards, and if something failed, I was supposed to identify it and go fix it. I can tell you that humans are not good at that kind of thing because we stare at a bunch of output, and first of all, we're not good at being vigilant at staring at a bunch of dashboards, right? Because you have this output overload with lots of information coming at you, and you don't necessarily know how to process it. And also, you start being complacent, right? Because the automation mostly works, and the systems mostly work. And then once in a while, they fail, and then you have to fix it. But by that time, you went to sleep and started texting your friends or whatever. And also, you have the reduced situational awareness because, so this was studies done in pilots. The pilot used to fly the airplane, and they knew how to fly the airplane, and now the automation's flying the airplane, so the pilot is getting deconditioned, de-skilled, and de-skilling works quite quickly, right? You forget how to do it, and then the new pilot doesn't even know how to fly the plane, right? They never had the conditioning for flying the plane. So if I bring up the Sally story, who knows the Sally story? The guy who landed on the Hudson? So one of the things that the movie doesn't mention is the guy was training himself in his spare time on very critical conditions. He actually trained on a simulator for what to do when the airplane fails. And this is why he was able to do it, because you can't just have this skill out of the blue if you never use it. The other one is loss of feedback. So this is in particular very prominent in coding. If I code with Stack Overflow, I go to Stack Overflow and I look up a piece of code and I have 1,000 upvotes and 3 downvotes, and someone saying, in this particular case, it didn't work for me or whatever, right? And if I code with GitHub Copilot, I don't have that. I have a coding suggestion. Maybe I have even multiple coding suggestions, but I have no rich feedback about what people think about it and whether or not this is going to be helpful, so I have to evaluate the code myself. Task interruptions. So this is an interesting one, right? Because I have seen people, this is relevant in both sort of writing and coding. if you have the suggestions enabled and you start typing and you're like, I'm typing this email and I have this thing in my head that I wanted to do, and then it just generates a bunch of text for you, like, whatever. And like now you've forgotten what you were going for, right? You have the cognitive cost of switching, and your flow is interrupted. So I've actually seen it in myself and other people that like they will have suggestions disabled, or at least disabled when they're doing like lots of coding or something, because like it's actually interrupting your flow. And this is like one of my favorite ones, task complexity polarization. So I think automation can make easy tasks easier and hard tasks even harder, because when we design automation, we're like, this is easy to automate, therefore I'm automating it, and here it becomes difficult, so I'm not automating this piece. I think Patrick had a slide where like technology replaces parts of the workflow, which would be pertinent here. It's like you get this and you're like, okay, this piece is automated, this piece is automated, this piece is automated, and in between there's a human operator dealing with this, dealing with potentially the harder task that is left, right? And not having the signals from the previous one, not having the task decomposition, right? They're basically oftentimes left holding the bag, right? So inevitably, the friction with the machine is getting blamed on the human error. I'm going for a lot of aviation examples. Probably could have a lot of examples from, I don't know, someone taking out an AWS data center with one line of code, and then of course it's like, oh, it's the intern's fault. It's like, no, you wrote the automation, right? They can take out an entire data center with one line of code, and it's not the intern's fault that he ran it. Like that's not what happened. So the deadly Boeing crashes here, at first, the first two that happened were actually blamed on the pilot, because the pilot had 60 seconds to recover the aircraft when the automation failed, and they were somehow supposed to do it for the situation they've obviously never trained for, and only after this happened repeatedly, we started asking questions about what the hell happened on the automation side. So we said that transformers are transformative. To me, like one of the most important things that happened, anybody familiar with this particular XKCD? One person, yes, I got it. So this particular XKCD talks about how some things in computer science are very difficult and some things are not, and it's hard to explain the difference. So it's like, can you tag if this image is in a national park? Yes, very easy. Can you tag this image of a bird? Give me 5 years and a research team. So now I can, right? Like this is mind-blowing to me that I can throw this at an LLM and it will tell me if it's an image of a bird and where the bird lives and if the bird is endangered and whatever, right? So like this is the most transformative thing. This is also why people talk about AGI. So this is a researcher that quit OpenAI talking about how AGI by 2027 is strikingly plausible. It doesn't require believing in sci-fi. It requires believing in straight lines on the graph. So we have more compute, therefore we're going to become, the models are going to become stronger and closer to a human. Not everything in the world works like a straight line on the graph. So a guy on Twitter saying, my 3-month-old son is now twice as big as he was when he was born. He's on track to weigh 7.5 trillion pounds by age of 10. There's a whole bunch of research about like we may or may not hit AGI and what can impede the progress on that straight line. Gartner also doesn't believe in straight lines. Gartner believes in hype cycle. So like, you have innovation and then you have peak of inflated expectations and then they start coming into disillusionment and then eventually you recover and get to plateau of productivity. And Gartner actually believes that we are hitting the disillusionment for particularly GenAI, right? Which is an interesting question. I keep asking this question, is AI winter coming? Anybody familiar with the term AI winter? A few people. It was mentioned a couple times at this conference. Just means it happened a few times before. It's when people get overly excited about AI and then basically throw a bunch of money at the capability and then the capability doesn't realize the productivity that was expected, so they get disillusioned and stop throwing money at it. Doesn't mean that the capability wasn't real. It just means that the people overestimated how good it was, and then they get disillusioned, and all the funding dries up, and no one wants to look at it anymore. So that I'm like, if you're in technology, you've probably heard of all of these things and how they were going to transform your business, right? And some of them did, and some of them didn't, and most of them are now generally disregarded. So people say either they're already doing it, or they just don't want to do it because it's not that interesting. So like, I fear that GenAI could become one of those thrown out transformations, and like, I actually don't want us to get there, right? Like, but I think if we keep spending as much money as we're spending on these models and not finding the killer application for it, it might happen. So how do we avoid this? So I think, for me, a lot of this is, and I'm going to speed up even more because I'm barely coming up on, anyway. So we're going to talk about workflow design. So there's two different parts of it, person, product. Because I don't have a lot of time, I'm going to talk about personal workflow with GenAI. So there's a lot of voices out there talking about the death of junior professional, right? So like, now as a senior, I don't need juniors because I can throw all my code or all of my marketing or of my legal stuff at GenAI, and they will generate the brief and whatever, and then the juniors don't get upskilled, and then the juniors can't find a job. And I don't believe that, but why do people believe that? What skill do seniors have that juniors don't always have? To me, that's recognizing what good looks like, right? If I'm a senior, I look at the legal brief and I'm like, yeah, that's good, or no, that's not good, I need to correct it, right? If I'm a junior, that could be a lot harder for me to do. So if you're in technology, you're probably familiar with these tools, and all of them work by implementing something that takes desired state. So I define a goal, I say, this is what good looks like, right? And this is my current state, and I can get from this state to that state by implementing certain actions, right? It's not just in technology that we have this, we can have this in behavior, so we can take test-driven development, right? And the test-driven development can be like, I write a failing test, right? Someone did it on stage yesterday, that was pretty cool. I write a failing test, and then I define what good looks like, and then I get to it by implementing the code that implements this. So we find this is a control loop, and we find this everywhere, right? You should be able to sense the information about what your environment looks like. You should be able to know what your goal is, right? What the good looks like. And then what decision you need to make to get from the state that you're in to the state that you want to be. And then you have some sort of actuator, someone that takes the action to reconcile the existing state with your desired state. And I think how you improve productivity in general is by having better information, making better decisions, or taking better actions. And you can attack all three, or you can attack parts of it. And this is like, in your organization, you have these loops in in the technical, or in sociotechnical sense. And if you start digging, it's control loops all the way down everywhere. So if we talk about creator to curator shift, right? One of the interesting things is, I think that here you are the loop. So you used to write code, and now you evaluate code. So you get output from GenAI, and now you need to sense if it's good, you need to compare it, and you need to make a decision and take an action. So this is another paper that came out like just a couple months ago. It's about task decomposition. So they said humans are better at understanding complex tasks after they've been decomposed into simpler subtasks. So this study they did, and I'm not super high level, they had a coding competition, they had people participating in coding competition, and they let them use GenAI proposals, and they decomposed the GenAI proposed solutions in various ways, and they found that experts and non-experts and LLMs themselves were better at repairing the well-decomposed LLM proposals, right? So if you decompose the solution into subtasks that humans could understand, they could repair it in such that it passed the unit test, it won the competition, right? So there's a lesson here in terms of productivity that if you were approaching coding with GenAI or writing copy with GenAI or I don't know what, right? One of the things is don't ask it to write your entire mainframe freaking implementation, right? Because it's probably going to be impossible for you to evaluate and repair the solution. So a lot of things in productivity, as we said, are about better metrics. So generative AI can generate more code, more text, more media. If you ask for more, you get more, right? One of very hated metrics that I have is more lines of code. Every now and again, someone decides to measure lines of code for evaluating how good their software development works. Usually they get more lines of code. Do they get more value? Usually not, but you know. So this is Goodhart's law. It says when a measure becomes a target, it ceases to be a good measure. So if you measure people on, I think I like this sketch a lot to explain this, right? If you measure people on number of nails made, you may get thousands of tiny nails. And if you measure people on weight of nails made, you may get a few giant heavy nails. And one of the things that becomes apparent from this as well is that the best way to improvement of this is just have both of these measures and potentially a few more, right? So one of the things that we want to do when we measure productivity is we want to have a balanced system of metrics. So a lot of times when people come to us, so this is process metrics. People often measure developers on process, right? And oftentimes when people come to us, they're like, we want to be faster. We want to deliver or deploy code faster. We want to write more code faster. And you start talking to them, you start evaluating what's happening in their organization, and you're like, your problem is actually quality. Or your problem is actually like you have no reuse, you keep implementing these new features and you keep not looking at the code that you already had and whatever. Another thing that people don't do when they measure developers is they don't measure market fit. So like if you're in sales and marketing, you constantly talk about market fit in some way. If you're in software, a lot of times you're like, users, whatever, who cares? But in market fit, you also need multiple metrics, right? So if I told you that I was making $10 million, does that sound good? Yeah. It does. If I told you that I spent $10 billion to make the $10 million, does that sound good? Probably less. So it's not that one metric is better or worse than the others. It's that you need all three here to estimate if your revenue is actually happening and is positive, right? And like you can have other systems of metric, not necessarily revenue, but like this is popular in SaaS, right? Customer lifetime value, customer acquisition cost, customer churn, right? The more balance you have in the metrics you measure, the better. And then the other thing that I see all the time is like you walk in and all of your metrics dashboard look like this. And then you're like, okay, does anyone know if this is good or bad? And people are like, I don't know. So if I look at this chart, what information does it give me? Not everything looks like a line on a chart, but let's say that this metric is a line on a chart, right? Does it give me any information about what I need to do? Not at all. So like, okay, what if you had like, this is green, so I don't need to do anything, this is good, right? And okay, maybe this is orange, so this is not as good. Do I need to take an action about this? Maybe. Like, do I need to just log it for observability purposes? Do I need to call someone? Okay, this is red. This is bad. I need to take an action. Who needs to take an action? How do they take an action? Are they empowered to take an action when you call them in the middle of the night, right? What the action is. So this is like a better way to approach metrics. Think about balancing the metrics and think about the metric being a narrative that describes to you what actions need to be taken when. So if you, in summary of this talk, all systems are sociotechnical, so automation alone is not going to improve your system, and GenAI alone is not going to improve your system. While GenAI has major potential for improving your systems, we need to design them with the human in mind, right? And then improving productivity and systems in general is all about the control loop. Find your control loop and find how you can have better information, make better decisions, or have better actions. So, this is it for me.